A rational inequality is an inequality that contains a rational expression. These inequalities have solutions that are in the form of either a number line graph or an interval notation. I'm going to show both solutions here. With these solutions, you have to be mindful of extraneous solutions, meaning solutions that will cause division by zero. So if you have a solution that's an extraneous solution, you got to get rid of it. It has to go away. So we're going to solve this rational inequality. 3x plus 5 times x plus 8 divided by x minus 2 is less than or equal to 0. So again, since it's set equal to 0, we're going to set the top terms equal to 0 each, and we're going to set the bottom as well, except the bottom is going to have not equal to 0 because it cannot be. And we'll solve each one of these individually. So subtract 5 and divide by 3. X is going to equal negative 5/3. Subtract 8 over. X is going to equal negative 8. And then we're going to add 2 over. And x cannot be positive 2. So here's our three answers we got. So we're going to draw a graph that contains these three and test for what's true and what's not. So putting them in order from smallest to largest, negative 8, negative 5/3, and positive 2, and I'm going to put a not equal to here just to remind myself that it cannot be 2. Now I'm going to pick some test points. So something less than negative 8, I'm going to call negative 9. In between negative 8 and negative 5/3, I'm going to say negative 2. In between negative 5/3 and 2, I'm going to say 0. And then something greater than 2, I'm going to say 3. So now I'm going to take all four of these, plug them into my inequality, and see what's true and what's not. So negative 9 first. So I'm going to have 3 times negative 9 plus 5, negative 9 plus 8 divided by negative 9 minus 2. And so when I do all of this up here, I'm going to end up getting negative 2. And is it less than or equal to 0? The answer is yes. It's true. So everything to this side here is good. And now we do it again with negative 2. Now, 3 times negative 2 plus 5, negative 2 plus 8 over negative 2 minus 2. And we go through all of this, we're going to end up getting 3/2. And is that less than or equal to 0? The answer is no, that's false. So everything in between negative 8 and negative 5/3 will not work. So let's do it again with 0. So 3 times 0 plus 5, 0 plus 8 over 0 minus 2. And when we go through all of that, should get negative 20. It's less than 0. So is that true? It is. So everything between negative 5/3 and 2 is pretty good. Finally, we can do it one more time with 3. So 3 times 3 plus 5, 3 plus 8 over 3 minus 2. And when we do all that, we should get 154, less than or equal to 0. So is that true? And this is not. So everything here is false. Now you may have noticed that this alternates. A lot of times the answers do, but not always. So it's always best to do test points to see. Make sure that it is good. So now we have our sign graph. We know what's good and what's not. So on a number line, -8, -5/3, and 2. So we know everything to the left of -8 is true, and since it is equal to, we're going to use a bracket going in this direction, and then -5/3 to 2 right here. Everything's good, so we're going to use, again, a bracket here going all the way to 2. But remember that 2 cannot be equal to, so we cannot use a bracket. It has to be a parentheses. So here it is in number line notation, number line form. In interval notation, it's going to be -∞ to -8, bracket. Then we're going to union it in another bracket for -5/3, and we're going to +2, which again has a parentheses. So this will be our answer in interval notation.